Hey, we're almost done. We got lesson 79 here today, and I'll get 80 done as well. I'm running out of t-shirts, so try to wear a different shirt every day, and I'm scraping the bottom of the barrel. This one's pretty old. This is from Easter about 52 years ago. Hey folks, let's see. You're going to need some homework paper today. You're going to need your handy dandy notebook for taking notes so you can use it on the test. You need your Spencil little light reading if you get bored watching this, but apparently I need to be making more birthday videos because it's going to earn me some money here on YouTube maybe, huh? Let me know when your birthday is and I'll make one for you. Let's see what we've got going on here today. Oh yeah, lesson 79, which is a prime number, right? Oh, wait, hang on, let me see. Yes, very special then in that case. You see it on there? 79? Yep, it's prime. Which means that not a lot of factoring to be done with that number. Okay. Trinomials. We've dealt with trinomials quite a bit. We got these things with three pieces. We've had lots of quadratic equations. Done a lot of factoring with these. You do lots of factoring with these things in math. They keep coming up. They're very, very common. Today we're going to use the greatest common factor. We're going to basically pull out of our trinomial everything, the biggest amount of stuff that we can pull out of every single piece. That is, what's common to each three pieces of this trinomial that we can yank out and put out in front and then see what's left. We want basically one of those x squared and something x and a constant left over. So they've got all these different techniques in the lesson, and because so many of these are set up with the variable being x as quadratics being left over, let's just simplify this process, okay? Let's go with kind of one theme here for today that we're going to apply to all the different types of problems that they're going to lay on us. And that is, we want to at first ignore everything else and just look at the very first term. If it's in the standard form, going from the biggest power down to the smallest, and there's one type of problem where you have to rearrange, but all the rest of them, put them in the right order. We want to look at just that first one, and we want to pull off, we want to factor out, we want to divide out everything that's not x squared. Okay? We want x squared to be left over, and then we'll do the same thing to the other two pieces, because that's the way they write these things, is so they can be left with a quadratic trinomial that's left over. So, x to the fourth, if we divide it by x squared, we'll get x squared. Okay, so x squared is what we can yank out of that to have x squared left over. And then we just apply that same exact thing to each piece. If I pull out an x squared out of this piece, I'll get 5x. And if I pull out an x squared out of this piece, I get plus 6. Now, I don't think that they ask you in all these. Maybe they do. But I guess that's the first step. We can then ignore that piece there, and we can work on this stuff here. And that's a thing that we did a few lessons ago, where we look at, sometimes we look at the first and the last, but this time we're only looking at this last term, and we're saying what are the factors of, in this case, 6, that would sum up to the middle term 5, positive 5. So in this case, you got 2 and 3. And it doesn't matter which order those go in, and I've fully factored out that original equation there. So once you get that first piece out of the way, the rest of it should look fairly familiar to you, and you're going to play that little game. And because we're going to factor out everything that's not x squared, it leaves us with the thing where we only have to look at this last piece and see what the factors of this are that sum up to that middle piece right there. Okay, that's the basic plan of attack that I'm going to take. The only trick is going to be when we have a negative sign in the front, that we have to extract a negative from everything else. Or, if you want to put it another way, we'll have to change the sign on everything else. So let me give you another one of these before I move on to the variations of these. I suppose this is a variance as well because they add a constant term in the front of 4. But again, I want to just look at this very first piece, and I want to say, what do I factor out so that I have x squared left over? Okay, what is not x squared in this? There's a 4 and there's an x. Okay, and if you want to just check it, you just go, what's 4x times x squared? 4x cubed. So I'd like to try to pull a 4x out of each of these remaining pieces. And so I go to here, if I can pull a 4 and an x out of that, I'm left with negative x, double check that, negative x times 4x is negative 4x. And now this last piece, if I pull out 4x, I'm left with a negative. 80 divided by 4 is 20, and x divided by x is 1. So I've got 4x, and then I've got this quadratic that I'm going to look at the last piece, negative 20. I'm going to think, what are the factors of negative 20? There's going to be one of them that's going to be positive and one of them that's going to be negative. So I could play this game. But I know they have to be 1 apart because I end up with basically like negative 1 here. So that means it's going to be 4s and 5s. 4 times 5 is 20. Which one's going to be negative? Which one's going to be positive? We know that one of them is going to be positive, one's going to be negative, but the negative wins. So the negative has to be slightly bigger in this case than the positive one. So negative 5 and positive 4 win the day. And there it is. It's fully factored out. If you want to check that, but you don't, you could do FOIL here and then multiply each piece by 4x to get back to there. But again, the trick is, look at that first piece and say, what is not x squared in there? 4x. Pull it out and then pull that out of everything else. Factor it down to small, to whatever, to the nth degree, to the very end, and you've got it done. Okay, so let's take up that special case of negatives. It is sometimes hard when they just put x, because there is understood that there's a 1 there, that there's a 1 as the coefficient. And when they put a negative, you might just want to throw in a 1 in the front of that as well, at least so you have a number to play with, okay? And you can see here that everything that's not x squared in that first term of this trinomial would be negative 1. Okay, so you can either think of it as pulling a negative out, which switches all the signs, or pulling a negative 1 out of everything and seeing what's left, or dividing by negative 1. So that's everything that's not x squared, and that leaves us with x squared. If I divide 1 by negative 1, I'll get negative 1. And x is still there. And if I divide 56 by negative 1, I get negative 56. Or if I pull out a negative, it switches the sign. Okay? So anytime you have to do that, just realize that the sign changed here. It was negative, now it's positive. This one here was positive, now it's negative. This one was positive, now it's negative. The signs just all switch. Maybe that's a better way to think of it. So I could look at this original problem like this, right? And I could just pull out a negative and then change all the signs and not worry about the ones being there. This piece right here is probably kind of nice because then I can start thinking about what factors of negative 56 sum to negative 1. Well, there's only 1 apart. 56 is 7 times 8. One of them is going to be negative and one of them is going to be positive. The middle term here is a negative, so that means the negative 1 is the winner. That has to be the 8. And the positive 1 is the 7. So there it is. Or you could write it as negative 1 and x plus 7 and x minus 8. That is also acceptable. They're both correct. The negative all by itself implies negative 1 has been factored out. Okay, so that's really the only trick Here is if you pull out a negative or a -1, all the signs switch and you get it down to this place here, and that's what we've done before, and you just split that thing up into its pieces and you go from there. Okay, I'll do one more with a negative sign in there. This time I'll put a number other than 1 in the front. The book gives this equation here. Again, we don't care about the rest of that. Let's just pull out everything that's not x squared out of here, and that would be -3 and an x. Okay? We're dividing this by -3x, so that leaves us with x squared, which of course that's what we're looking for. If we divide -6x squared by -3x, we get a positive. 6 divided by 3 is 2. X squared divided by x is x. And if we take out a -3x out of this, the sign changes. 72 divided by 3 is, I don't remember, 18? How's that sound? It doesn't sound right. 18 times 3, no, that's not right. 72 divided by 3 is 24. 24. Okay, 24, and we divide it out in x, so there we go. We leave that out in front, and we're going to play this game again. We look at this piece here. -24 is made up of two factors that sum to +1. Since it's negative, one of them's negative, one of them's positive. We need those two factors to be 2 apart from each other. 6 and 4. 6 and 4. And because the middle one is +2, the 6 has to be the +1, and the 4 has to be the -1, so that we end up with a positive number. 6 and 4. There we go. Fully factored. We're done. The only change that they're going to make, well, there's one problem where it says rearrange first. I'll do that one first, and then I'll do like the trickiest one. I don't know, call it tricky, but here they got P's and K's. We just have to decide which is the one that's like X. Here, is it the P or is it the K? Well, if it's like X, it has to have X squared, X, and then nothing with X. So you can see here there's K's and everything, but they're all just K to the 1. So P must be like X is, and that helps us determine how we should order this. So P squared goes first, and then the thing with just 1P goes next, and then this is like the constant term here at the end. Now we look at the front, we say what is not P squared? 7 and K. We look at this term, we say if we take out 7K, or we divide this by 7K, we get -2 and P. And if we take out a 7K out of this one, 105 divided by 7 is 15. Minus 15, and we take out the K, and that's what we're left with. So we got 7K. Instead of X, we're going to have a P. We got a -2P and a -15. One of them is going to be positive, and one of them is going to be negative. We think about the factors of 15 that sum up to -2. They have to be 2 apart. 5 and 3. 5 has to be the -1 because it ends up being negative. 5 is bigger. There we go, fully factored. Okay, one more. We'll be done. And then we've got one lesson to go. And that would be if there's another one with 2 variables. This time they put everything in nice order for us. X squared. And again, we're looking at this and saying, I just need x squared, x, and a number. So what in the front here is not x squared? There's an x squared and a b that's extra. Okay, you multiply that through, and that's what it is. So we got to pull that out of each of the other pieces. We're going to have what? We're going to pull the b and an x out of here. Sorry, an x squared and a b. And leaves us with 9. And then here we have 20. Pull the b out, pull the x squared out, and we're down to the place where we're going to factor that. And I'll leave you to that for the solution because I'm running out of time. Okay? There you go. That's lesson 79. We'll see you soon for the next one.